We try to make this session as interactive as possible because we are talking about existing solutions to deliver interactive live broadcasting experience married and coupled with OTT platforms. I'm glad you have joined, and the day after the customers event is quite heavy, I know, so please lay down and feel comfortable. And let me help you introducing ourselves. Yes, this is me, İlker. I'm an enterprise media architect from Akamai, working for Akamai since 6 years. I've been more or less a sales engineer for many years. Now I'm working for the technical solutions specialist team. On my right hand, we have Jesus. He's an Epic Lab founder and chief media engineer. And at the very right hand, you see Alfonso, Epic Labs founder from. And yeah, he's also a CEO, I see. Nice, great to meet you so far. So today we have talked about Epic Labs introduction already, and we will be talking about the need, the challenges and opportunities with this real-time and interactive video solutions which we will be talking about. And then we will be introducing the architecture, what is underlying there. So we will talk about this existing solution and tell you how it works with Epic Labs and how it will scale with Akamai. And at the end, I hope more and more people will join. And I see we have almost 20 people here. And if you have questions, we are more than happy to help answering your questions. And with this, I would like to hand over the microphone to Alfonso, and you will realize a shift in the accent, more going to a Spanish experience.
All right. Thank you very much, Ilker, and thank you very much, Akamai, for having us here at Edge. And thanks to all of you after a very intense week here at Edge, and also after last night. Very much appreciated. All right, so we're Epic Labs. We're a software innovation center. We're very focused into the media space. We're a fairly young company. We started operating at the beginning of 2016. We're a team of 24 media software engineers and product designers. My 3 co-founders, including Jesus here with us today, have a background at Akamai. They were doing product engineering for Akamai on the media space for over 8 years. Myself, I come more from the cloud infrastructure world. I come from Dell EMC. So we're a software innovation center for the media space. What this means is that we're helping broadcasters, content owners, content producers through their digital transformation and innovation processes. All right, so what this means is that on one side, we're helping the more traditional broadcaster shift from the SDI cable into the IP world. We're helping them leverage software, create software-defined networks, and effectively virtualize workloads and move workloads into the cloud. On the other hand, what we're doing is that we're helping the same broadcasters, content owners, content producers leverage on their audiences and on their content so they can create more immersive experiences, they can create new engagement models and new monetization models. We're services companies. Whenever it's possible, as part of our value prop, we propose and engage with our customer engineers, merge them with Epic so we can leverage on our methodology. We help then co-create, co-engineer. And even though we're a services company, we're also doing a lot of research on ourselves, and we're creating products mainly on 2 spaces. We're doing a lot of research on deep learning applied to the media space. So we're getting very smart into what is happening within a video clip, within a video stream. We're enriching metadata on those streams so that way we can get very smart decisions. We can get into smart advertising, moderation of content, etc. And the other area that we're doing a lot of research is the one that brings us here, which is the one around real-time video interactive experiences, which is the one that we're going to be talking across the session. Here are some of the customers that we're working on the media space for. Some of them here, so thank you very much for coming. We're also part of the Dash Industry Forum. We're working on the Dash JS player, and actually Jesus here with us is leading most of the effort out there. So we're going to get into the detail now. Ilker, it would be good if you could tell us some of the challenges that you're seeing on OTT. What do you think that user-generated content is going to be interesting for this space?
Thank you very much, Alfonso. So there is a need for real-time and interactive video, yes, we can say. Now let's have a look into this nice slide here, which you can see that now, 2016, we see a decline in the scheduled linear TV experience. So it's going down, but at the same time, you can see that the streamed on-demand movies for short video clips are raising. So there is a shift in how we are interacting with media content. So that's a fact. And then we don't want to forget the importance of live content. It is almost 50% of how we are consuming content. And out of that content, which you can see here, which we are consuming, 10% of that viewing time is user-generated content. So that said, if you look down there, you see that the user-generated content for live UCG is quite small. So there is a lot of room for this streamed live user-generated content. And we hope to change the game in the future by solutions like Epic Labs, how they are introducing it into the market, to be able to disrupt the market. So disruptive is a nice wording we heard at the beginning of our opening keynote from Tom. And it's all about changing the expectations and the behavior. So let's have a look in the history. So we can see that 2015, all the personal broadcasting stories began with Meerkat and Periscope, where they have launched their services in March 2015. And August 2015, we saw Facebook Live coming into the market. Now, you guys know Facebook Live. We are streaming live almost every day. And you also know Twitch, a company acquired by Amazon, who started presenting online gaming experience through their platforms. And esports have been really, really successful for many years. But how can we build the bridge into the OTT? How would it be if you, as a user, as a content creator, if you would like to bridge this experience into the OTT, if you would like to do it like yourself, as Meerkat or Periscope is doing? So you need a massive scale. And to be interactive, it is tough to manage. Would you like to do it yourself? How do you want to monetize it? Well, you don't want to share your content maybe through Meerkat or YouTube. So brand awareness is an important topic here. And you have to also make sure that the content you are sharing with your audience is legal. So you have to need a way to control that content. So what are the opportunities for real-time and interactive video? Content is king, right? Also, user-generated content is king. So if you look here to the top 10 Facebook video creators from August this year, you can see that, what is this? Unilad, he had 3 million views in 1 month. So there is huge opportunities here. And you know it, we know it, and we want to build the bridge into the OTT with these kind of experiences in long term. So that said, the only limitation is your creativity combined with the technology. So if you look at the stats from Adobe, that more and more creators are able to combine the technology to be more creative in long term. That said, with these kind of solutions, we want the creators to be more creative and combine their solutions with our technologies. And with that, I would like to hand over to Epic Labs again, and then they will tell you more about their solutions.
All right, so we're going to get into the fun part that Jesus is going to be leading us. So, Jesus, we're talking about interactivity, interactive broadcast, interactivity broadcast. From a technology standpoint, this could be a bit contradictory. So we're approaching the architecture here. What type of technologies are you looking at in order to approach both the interactivity side and be able to reach to a massive audience cost effectively?
Mm-hmm. Yeah. What we are doing here, is okay. What we are doing is in the technologies that we are
Is that turn off?
No, it's okay. It's on.
Hello.
Okay.
Yeah.
Okay. So what we are doing in the platform that we have built is we are mixing the benefits of using a platform or using a set of technologies like WebRTC that are thought for video conferencing, are set of technologies that can run in the browser and that allows one-to-one communication as if you were using something like Skype. And at the same, we are using this set of technologies because this allows very low latency, something that is below half a second. And they are very thought for that. They are very thought for optimizing the low latency. So whenever they need to reduce the quality, they are going to do that with the unique goal of reducing the latency. So we are using them, and at the same time, we are also leveraging the use of DAS, HLS, and RTMP, that are technologies, are protocols that are thought to be streamed using Akamai, using a CDN, and then we can reach massive audiences. What we have done is we have built the bridge between these two different technologies, build some algorithms that are able to adapt, to transform what is happening in real time to something that can be streamed to a massive audience. So this is what we are doing today.
Very good. And what type of latencies are we talking about when we're talking about WebRTC versus the broadcast protocols, HLS, Dash?
Yeah, we are talking about latencies that are below half a second when working with WebRTC, as I said before, and with the latencies that are going through 10, 15 seconds when talking about DAS or RTMP or DAS or HLS. Okay, we are optimizing the streams that we are providing to get this reduced latency, and we are also working with Akamai on new stuff, new packages that are going to allow us to reduce the latency to 5 seconds, even in the massive audience side. Okay.
Yep. Now we're talking about WebRTC. WebRTC is not just a technology, but a set of technologies that are widely available. How do you encapsulate all the complexity about these architectures or these technologies, these reference architectures for WebRTC?
Yeah, basically what we are doing is providing a set of tools to make easy the consumption of these services. So there are two parts. There is one part that is the server side that we are hosting. We have a platform that is a cloud-based platform that runs on AWS right now, and that is implementing all the server side of our solution, all the transport, all the mechanisms that are behind the video manipulation. And this is the server side. Then in the client side, we also have SDKs for the client, for Android, for iOS, and also for JavaScript that you can use for integrate the services that we are developing into your applications. With just a few lines of code, you can start using our service. Okay. So just to give you an overview about the architecture, I'm going to present some of the points that we are building. What we have in the bottom left are the users that would like to start using the service. They have devices that could be Android or iOS, or they can be using a computer with a browser. They would like to start streaming. They would like to start publishing content. For that, they are using the SDK that we are providing. And the first thing that they need to do, to start publishing is using they need to be authenticated. We are publishing content, so we are limiting the people that can be publishing content. So for that, we are providing an SDK that you can integrate with your servers, with your backend, so you can generate a token that gives access to the user that you select to the system. Okay, so we have a server SDK that you can integrate with your backend to authenticate your users. After that, what we have built a platform that is a services-based platform in which any of the components that we have has a very specific function that I will mention before. Every node or every instance of the platform is registered in a distributed index of elements or distributed index of resources that are available, so we can scale. The platform is thought for scale horizontally, so we can grow and grow and grow in number of users without any problems, both in our server side and also in the delivery side, because we are leveraging the use of Akamai. Okay. We are using load balancers for balancing the web traffic to the entry points of our system, and we have mainly two different. This is the pointer. Well, okay, we have a REST API that is, besides other thing, is the entry point to the system. Is the node or the type of instance that is the one receiving the first request. Whenever a user would like to join a room, or whenever a user would like to start using the system, he's going to request, he's going to ask for that using the REST API. Okay. Once the user has joined, then we also have a second public API that is based on WebSockets. That is the one that is implementing all the room logic. All the room logic, all the notification regarding who has joined a room, who has left a room, all this logic is implemented here in the messaging in the WebSockets API. it is also configuring all the routing, all the media routing that is happening in the real-time media servers. That is one of the most important points of our system. We have real-time media servers that are the one implementing WebRTC and are the ones in charge of doing the transport of the video and the audio in real time. Below we have turn and stun servers that we are also hosting that are the ones that are making the system to be network friendly. So whenever you have a firewall or you have a complex network behind you, the turn and stun servers are going to help to negotiate the connection and to make this happen. Okay. The last point of the diagram are the broadcast servers. These are the ones that are doing the magic, are getting what is happening in real time, getting the WebRTC streams, and they are converting everything to RTMP, DAS, and HLS. So we can push all the output in Akamai to be delivered. Okay. So how this works? We have seen the architecture. Let me explain a bit about how this is working. As I said before, we have a services architecture in which any of the nodes of the system, any of the type of instances that you have is registered. So we have a distributed index of all the elements that are part of the platform. Here we have. In the other side, we have a backend that is something that is part of your implementation, and we have users that would like to start joining a conversation using one of our SDKs, as I said before. So we have SDKs for JavaScript, we have SDKs for iOS, and we have SDKs for Android. As you can see, it's like 3-4 lines of code, and you can start consuming the service. Okay, it's very simple, and you can consume the service both to publish content and also for watching the content that is being published by others. Okay, so you can see it's like creating a room, connecting to a room, and start publishing content, just as easy as that. Before start publishing content, as I said before, you need to be authenticated. You need to have a token that is valid for publishing content. So this is the first thing that the user needs to do, getting a token. It is using your backend that at the same time is using one of our server SDKs. Once the user has a token, we need to request or we need to send a notification to the REST API about our intention to create a room. We are using the REST API for that. We are asking the REST API for the room, and what the API is going to do, the REST API is going to allocate resources. Is going to allocate resources that are going to be the ones that are going to host the room. We need to have different type of instances. We need to have a messaging server. We need to have a list of turn servers that are going to be used to set the connection. We need to have a real-time media server. We need to have capacity in the broadcast servers to do the transcoding and all the things that we are doing. This is part of the things that the REST API is doing, allocating resources so the connection can be managed. The REST API is going to allocate resources, and then the connection could start happening. Using the WebSocket, the user is going to join the room. We are going to start negotiating the connection using the stun and turn servers. And finally, we are going to start doing the video and audio transmission. Okay, this is happening in real time with a latency that is below 200 to 400 milliseconds, something that is similar to what you can get when using a video conferencing system. And then once the data start arriving to the real-time media server, it notifies that to the broadcast server, so we can start relaying what happened in real time. Is started being relayed to the broadcast media server, so we can do all the conversions. And what type of conversion we are doing? As I said before, real-time media servers are optimized for getting low latency. So whenever they detect that there is something in the network that could impact the low latency, they are applying algorithms, they are applying mechanisms to reduce that latency. This could be lower the quality, this could be drop frames, this could be increasing the keyframe interval. There are a lot of things that WebRTC is going to do with the unique goal of reducing the latency. This is okay for real time, but this is something that is not compatible at all with HLS or DAS, in which you have players that are pretty sensitive to these kind of things. It's like you cannot have time gaps, or at least this is not something that is supported in a generic rule. So we need to skip that part, or we need to solve that part. in the broadcast servers. What we are doing in the broadcast server is we are repackaging what happened in real time. We are repackaging from SRTP to RTMP. We are transcoding what happens in WebRTC is using BPH and is using Opus. We need to transcode that to H.264 and AAC. We are also doing video composition. So all the streams that arrives to our room, all the streams that are real time, are composed in one single room, and we are providing one single output for our RTMP, HLS, and DAS. And we are being sure that we are synchronizing the streams. So whatever arrives in real time needs to be synchronized at the output. Okay. And the last point, that is one of the most important ones, we need to do all these steps, taking into account that we need to reduce the use of the CPU. Most of the things that we are doing here are very expensive in terms of CPU, are not easy to scale, and we need to keep the use of the CPU as low as possible to be able to scale. Okay. Things that we are doing in the transcoding is what I mentioned before. We are applying some mechanisms there to be sure that we are generating a signal, we are generating a stream that is fully compatible with Akamai and with players. So we are filling the gaps in case there are gaps. There are drop frames, for example, in the real-time media servers. We are filling all the frames. We are also ensuring that we have a constant frames per second. We are ensuring that we have constant keyframe interval. We are applying a lot of modification to be sure that the signal is going to be, the stream is going to be compatible with both with Akamai, in case we are pushing RTMP, and also with the players. Okay. The last point is about Akamai, the products that we are using at Akamai, and for that part, I am switching back to Ilker.
And thank you very much, Jesus. Now we have seen the live broadcasting side, the architecture, how it works, and now with the next slides I would like to introduce you how Akamai can help to bring that experience to the audience in a scalable and efficient way. Thank you. So the broadcast servers are publishing the content to us either via RTMP or HLS dash through our pass-through platforms, and then we will be able to deliver that experience in a scalable way that our customers are expecting. Let's have a look how this looks like. So how can this scale even more? The broadcast servers can publish the adaptive bitrate streams to our accelerated ingest service. So that said, we could in theory also put an ingest acceleration source, which then can accelerate that experience, that live stream, that live broadcast via UDP to our ingest servers. And at our ingest servers, we are able to receive that content and also put it on our net storage so that that content could also be consumed via DVR. So let's have a look further. Media acceleration and efficiency. This is something which you have heard a lot today. I don't know if you have been to the media innovation zone downstairs, where we have also introduced how it looks like or how the content is being shared between the clients and also delivered through other CDNs. Now with this slide, I would like to tell you more how it works really under the hood. So we have the edge servers, and now the edge servers can deliver that experience via quick protocol in an accelerated way to the clients. So that said, the clients need an Akamai SDK so that it will be able to accept the quick requests. So we have these SDKs today available for the accelerated way for iOS and Android, and also or for HTML5 browsers as a JavaScript SDK. And then the next version of this media acceleration SDK is part of the efficiency story. So with the next or with the latest release of our beta SDK, which is now supporting also the WebRTC data channel. Let's have a look how we are creating this WebRTC data channel on our platform. To be able to do this, obviously, we need a signaling infrastructure. And part of that signaling infrastructure is also that place where we have our stun servers placed so that we know the IP addresses of all our clients so that they can start communicating with each other. Once the signaling request will be established. So the signaling request will go through our edge servers always. And then we make an upgrade request via WebSocket to our signaling server and initiate the signaling. And we see that also that we are doing integrity checks and beaconing through the edge servers also to the signaling servers, but we will talk about it later. So once the signaling, as part of the signaling is also that we have to make a stun request so that we know how we can reach any client through the internet, or how the clients can communicate with each other. So just one user wouldn't be sufficient to be able to talk to each other. So we'll wait for other users to join this experience. So once more clients are coming in and making these, establishing the signaling, we know where these clients then are, and we can start building the WebRTC data channel so we can signal them to talk to each other. And once this is established, we will let the clients know that they can get content from other clients as well, so that they can share this experience in a peer-to-peer related network, which we are making use of, where we are making use of WebRTC data channel. And as more and more users are joining, more and more efficient will this be experienced. So we have seen downstairs, or I don't know if you have seen it, and if you want to see it, you are more than welcome to come downstairs and see it, the Media Innovation Zone, where we can demonstrate how this looks like. That's it so far, and the best thing is to demonstrate you how the live broadcast experience would look like, and with that I would like to hand over to Alfonso again.
All right, thanks for that, Ilker and Jesus. Yeah, so let's get to see the technology in action. The demo that we're going to be seeing, this is for a broadcaster in Spain that it's a common customer of Akamai and Epic Labs. This is a broadcaster. They have a bunch of different celebrity shows. The one that we're going to be seeing is one that is called Big Brother. I'm sure that somehow you're familiar with it. So what they wanted to do is they wanted to have some type of interactive experiences with the audience. So that way the audience will not be just receiving the content on prime time, but somehow the audience will be able to interact and influence some of the actions that the celebrities would be taking. Now, they could have done this going through Periscope or Facebook Live. However, the big challenge there is that the whole audience, all the people that is watching the content will go through those other channels. They will go to Periscope or Facebook Live. They're losing the users. They're using the ability to monetize or keep the engagement with those. So we're going to see this working. Basically, what we're going to be seeing is their app in action. They're consuming our SDKs, so that way the whole experience is within their app. This is their app. The user can log in with their user password or with Facebook or where have you. And here they have different type of contents that they can access. They will go to for the Epic Labs a solution, and then here you can have the different celebrities that are part of the Big Brother. And then you can choose. I want to see this specific girl. And then you can start chatting with her, similar type of experience to Periscope. You can send her some hearts. You can ask her some questions. How do you feel? What are you going to do? Etc. You can send her a flower. All these flowers, all these different items that you can send to the celebrity, it's something that you need actually to purchase with some virtual tokens. In this case, we're integrating with Google Wallet. So you go there, you pay $20, you get some tokens, and then you're able to send her a rose because it's your favorite celebrity, and then she's going to feel good, and she's actually going to be talking to you live, and she's going to be saying some fancy things. She's going to say, thank you, you send this to me, and the celebrity is actually talking to you. This does not need to be on prime time. This could be on a Tuesday morning if the celebrity or the audience have nothing to do. So that way you're also leveraging on keeping the engagement with the audience, not just in prime time, but in some other times. In this situation, in this specific use case, we're also defining some specific challenges for the celebrities. So these celebrities, they are within a house for several months. And you can, we're engaging with this one, and you can send some challenges to the celebrity. In this case, what time she's going to wake up. Now it's 8:50 for this type of celebrities to wake up at 8:50 on a weekday. It's a big deal. So you can influence that, and you can say, well, I'm going to give you 5 extra minutes. Again, I need to use my virtual tokens in order to influence the behavior. Some of the challenges that we're proposing is this lady, she needs to walk for a certain distance. So again, she's not behaving well. You want to punish her behavior in the house. So you, again, pay some virtual coins, and then she needs to walk for an extra half a mile, half a kilometer. Some interesting use cases that we're evaluating as well is in terms of clothes. So it could be an Amazon Prime box that arrives into the house. There's different clothes from Sarah or from Mango or Gap or where have you. So you can try on the different clothes, and you can say, well, which one do you like most? So that way you can introduce brands, new revenue models. You can even introduce a type of a bottom or something. So if you like the clothes that she's wearing, you can buy them straight. Other challenges, you want to see me singing, what type of song you want me to sing, etc. So again, the purpose for this is just, I'm receiving the content, but I just want to influence how these celebrities within the house are going to be behaving. This is another example. We're talking about WebRTC. These two guys, the celebrity and the fan, are talking WebRTC, and within them, real-time video conversation, high quality. What we're doing is that we're capturing that. We're getting a video composition of that screen, and then we're throwing that, we're ingesting that into Akamai for a massive delivery cost effectively. If you're in the audience, you're behind the audience, you're consuming a broadcast protocol, it's cost effective, wide reach, high quality. If you want to get into the interactive point, what you would do is you would switch into WebRTC. So you're switching in between both technologies seamlessly. We're providing a moderation tool as well. This is very important for broadcasters, so that way if you're going to have somebody from the audience jump into the stage and interacting with the celebrity, you want to make sure that the content that they're going to be talking about is appropriate for the sensibility of the audience that are going to be watching. So these are just some examples of the things that you can do. What is important here is that the whole complexity around WebRTC, which is not just a technology, but a set of technologies, a set of references, architectures, the complexity around video, it's something that is completely isolated for the broadcaster, for the guys that are building this app. We're providing the SDKs for Android, for iOS, for JavaScript, and we're also providing all the elements on the architecture that Jesus was sharing. We're providing those in the cloud. So that way, the guys who are building the app can focus into that. They can focus into the experience that they want to build. They can focus into the experiences, into those challenges that we saw, those crazy challenges. We'll not come up with those ideas, but I'm sure the crazy producers that are thinking about how they can engage with the audience, they will come with those ideas, and then they will be able to consume the SDKs, so all the complexity around the technology gets isolated for them. And at the same time, we're leveraging all the good things about the Akamai's technology, so that way we can enrich the solution with some of the technologies that we're seeing here. You want to comment a bit?
Oh, yes, I would like to also share some closing words here on our end. You can see that there are a lot of components in this whole end-to-end workflow, and things are getting really complicated. It's not just one server, there are many servers, we have signaling servers, and it's getting complicated. And to be able to do this, you need a scalable solution. Even though it's for WebRTC on the audio-video channel side, or may it be on the delivery side through Akamai, things are getting complicated, and you want to be prepared for it. With that, such kind of solutions also require really low latency interactivity. So low latency is a critical point here, and to be able to offer such a smooth experience, the result needs to be really in almost real time, we would wish, but we are not there yet. At least with our solutions, I don't know if you have seen the sessions from yesterday from Will Lowe and Phil Harrison. We have demonstrated our low latency solutions, and we also have another low latency solution downstairs in the Media Innovation Zone, where we are able to show you and demonstrate you that we can break down the experience theoretically low down to a couple seconds, and in a much more smooth way, which is today already working, and it's already supported us with Media Services Live, where we have a latency about between 5 to 10 seconds. And we are working on low latency to be able to provide more interactivity experience solutions with Epic Labs. And that said, yeah, we are here. We are from Akamai. We are from Epic Labs. And we would love to open the Q&A and panel session. Sorry?
We have 3 minutes, so we can get some questions.
Yeah, so you're more than welcome to ask questions or share your feedback with us. No? We have a couple minutes. Thank you very much. I have some questions. Maybe you would be also interested about this. What about security? How can we make sure that only legal content is being consumed here? Maybe some of you had also the same questions, and I thought, let's ask him.
Yeah, there are two things regarding security. One is enabling the possibility of accessing or not accessing the system to any user. And for that, we are using the token authentication that I explained before. So you have an SDK that allows you to generate tokens and give access to specific users. This is one. The other one is that WebRTC is using encryption by default. So every traffic that is traveling from the user to our system is encrypted. So there is no security problem there. And then once we have converted the stream into our servers to something that is to RTMP, Dash, or HLS, we can convert or we can leverage the use of any DRM system to encrypt the content and then use the security mechanisms that are needed at that place.
Thank you very much. And another question I would have is, obviously, you want to make money out of it, right? So I see that people are sending diamonds, and that shouldn't be the only monetization model, but could we also insert ads within this experience? Let's say if it's on demand, are there opportunities there?
Yeah, absolutely. So in this case, this use case for a traditional broadcaster, so they are looking forward to monetize on the more traditional advertising that you will see on linear TV. However, this is something that is complementary. So we've seen some of the use cases here. We can use virtual tokens to incentivize the behaviors that those celebrities are gonna have within the house. You can get into it, buy some flowers, etc. And also on working with this broadcaster, we're seeing interesting opportunities on sponsoring, such as the example that we show. So we can introduce brands. The celebrities can interact with the audience talking about a brand, and this is something that it could be very, very enriching. You can wear a dress or some sunglasses or what have you. The celebrity is going to be talking about them. People are going to be chatting. You can have somebody interviewing as well, so you can start talking about the brand seamlessly. It is fairly easy to introduce a button there as well. So if you like those sunglasses, you can go there and buy them. Pretty straightforward. And of course, as you mentioned, it's easy to introduce some type of banners or what have you. Because at the end, what is very important here is that these broadcasters, they have, besides the content, they have a massive audience. So if they were to have this type of real-time or interactive broadcast somewhere else, within Periscope or Facebook Live, they're going to be losing those users, and by losing those users, they're losing the opportunity to keep them engaged and potentially monetize them. So that's why we're working with these broadcasters. For them, it's very important to keep all these type of experiences within their app, so they can keep connecting with the users. It could be just the experience, which is just great, but in addition to that, they could leverage on this type of monetization models.
Great, thank you. So I could also imagine that AI could come into the game and see, hey, this guy is wearing Reebok sneakers, and then pop up an advert being placed there so you can buy it. Yeah. So there is a lot of room here we can see. And that said, again, it's all about our creativity combined with the technology we are able to offer you. And we hope that you guys, our developers in the community, are more creative and offer the next solution with us, so that we stay here again next year and tell about the next thing which is happening soon, hopefully. That said, we would like to say thank you for joining us. And now you're allowed to clap, please.